Welcome to the video for scientific notation. Scientific notation makes a lot of use of the exponent rules. So if you're not comfortable with the exponent rules, you might take a look at the video for exponent rules and also the video on what 0, 1, and negative and fractional exponents mean. Negative exponents are very important in scientific notation. To add numbers in scientific notation or subtract numbers in scientific notation, we do the same thing essentially that we do with regular numbers. We line up the decimal point because we want to add the ones and the ones and the tens and the tens and the hundreds and the hundreds. Gets a little more complicated with scientific notation though, because this is not really where the decimal point is. What we're saying here is that to get the distance to Neptune from the Sun, we have to multiply 4.503 times 12 tens to get that distance. It's obviously a very big distance. That's why we're using scientific notation. So the decimal point is actually 12 places to the right of where we see it. So to get the decimal points really to line up between the two numbers, we need to get the exponents on the tens to be the same. So I'm going to rewrite 4.503 times 10 to the 12th. I'm going to call that times 10 times 10 to the 11th. So I still have 12 tens, but now I can multiply my 10 times the 4.503. And then I can subtract my 1.496 times 10 to the 11th. And I'm actually, since it's scientific information, we really don't want anything more. We don't want to add any digits to the right-hand side because those digits are telling us how accurately we know this number. So I am going to, as I do this, I'm going to think about that 1.496. I'm going to round it off to the same place as the 3. So I'm going to call that 1.50. I go up to 1.50 because the 6 is greater than 5. I add 1 to the 9 and it carries over to the 5. So now I'm subtracting, and I can do that just the way I normally would. 45 minus 1.5. I'll take 3 minus 0. I get 3. And then 0, I borrow to get 10. 10 minus 5 is 5. Then 44 minus 1 is 43. And it's then times 10 to the 11th. Because I haven't really changed that. So I'm still at times 10 to the 11th. With scientific notation, there's one additional rule. We have to get this back to the point where we have a number between 1 and 10. We only want one number to the left of the decimal place. So I can now call this 4.3 times 10 times 10 to the 11th, which was times 10 to the 12th. So that's the distance when Neptune and Earth are lined up. That's the distance between Neptune and Earth. So Neptune is 4.353 times 10 to the 12th meters further from Earth than from the sun than the Earth is. We can do a quick division. Distances in the solar system are sometimes referred to in astronomical units, which really just means how many times further is it than the Earth. So the Earth is 1 astronomical unit from the sun. If we want to see how many astronomical units Neptune is, we'd see how many distances to the sun from Earth are in the distance to Neptune. So we actually can take 4.503 times 10 to the 12th divided by 1.496 times 10 to the 11th. And this is where our exponent rules really come into play. Because I can now say I have 10 to the 12th in the numerator. I'm going to divide by 11 tens. I'm really going to just be left with 10. So I can cancel this, and say 45.03 divided by 1.496 is the number of astronomical units. And all I did there was take my 12 minus my 11, and that leaves me 10 to the first power. I multiplied that 10 to the first power times 4.503. Now, I'm not going to try to do this part in my head. I'm going to bring up my calculator. 45.03 divided by 1.496 gives me 30, actually 30.1. And I'm going to write 30.10 because each of the numbers has 4 what we call significant digits in it. So I want 4 significant digits in my answer. So I'm going to take 30.10. And AU is the abbreviation for astronomical units. So when we multiply or divide, we actually use our exponent rules. And it's actually a little bit easier than adding and subtracting because we don't really need to get them to the same exponent to begin with. It's kind of like fractions. Multiplying fractions is actually a little bit easier than adding and subtracting them. Another example where we're going to talk about multiplying and dividing and hopefully get into some negative exponents. There's was donating blood the other day. It was actually a platelet donation, so I donated a pint of blood, but the machine also took out a double donation of platelets. Typically, a pint of blood has 3.2 times 10 to the 11th platelets, and I donated twice that. So kind of watching as I went along, in order to increase the amount that I donated by 2 times 10 to the 10th platelets, it took 128 seconds. So the question is, how many hours would it take for the whole donation? So what I need is the number of platelets, the number of hours per platelet. And I'm given the time in seconds. I'm sure a lot of you can find the number of hours per platelet in different ways, but I'm going to use the method that I showed you in the unit conversion video. So I'm going to say I want hours per platelet. I have seconds per platelet. I have 128 seconds per, make a big line, 2 times 10 to the 10th platelets. And I'm going to multiply by 1 minute per 60 seconds. Already drawn the line, I don't need to draw it again. 60 seconds. And what we found is that just like with a fraction, those seconds will cancel out. And if I do this math, I would have the number of minutes per platelet. I really want the hours per platelet. So now I'm going to multiply by 1 hour per 60 minutes. And once again, the minutes will cancel out. So now I can actually go in and do that math. Didn't want to erase the whole thing. There we go. And I'm going to end up with that 10 to the 10th is actually going to end up being 10 to the negative 10th. Because it's, as we talked about in the video on what negative exponents mean, a negative exponent really just means that it should be in the denominator. So it's the negative exponent means it's a reciprocal. So if I have 1 over 10 to the 10th, that's like times 10 to the negative 10th. And I'm going to do the rest of it. 128 divided by 2, I can call that 64. I'll just do that in my head. 64 divided by 60 divided by 60 equals 0.0777. 0.01777. Actually, I'll round it off to 8. But this is not scientific notation because the number, I have my 10 with an exponent, but the number that's multiplied by the 10 has to be between 0 and 1. So I'm going to actually multiply this part of the number times 100 and divide this part of the number by 100. So times 100, divide by 100. And that's actually going to give me, when I multiply by 100, I move the decimal place 2 places to the right because the number gets bigger. End up with 1.778 times, if I have 10 to the negative 10th, I divide by 100, I divide by 10 to the second, I subtract those exponents, and I have 10 to the minus 12. And this is hours per platelet. So it takes a really small amount of hours to donate 1 platelet, which makes sense. Trust me, that says platelet. Because you're donating a lot of platelets at one time. So I need to donate 3.2 times 10. And you'll notice this is the one place where we use the x for multiplication. Times 10 to the 11th platelets. And I'm going to multiply by 1.778 times 10 to the negative 12 hours per platelet. And if I look at that, I'm going to have 10 to the 11th times 10 to the negative 12th. I can actually add those exponents, although one is a negative. And I'll soon have a video on negatives, but if I have 11 plus negative 12, that's the same as 11 minus 12. I have 10 to the minus 1. And then I have 1 point. So I've multiplied the 10 to the 11th and 10 to the minus 12th. Now I have to multiply 3.2 times 1.778. And fortunately, I still have that on my calculator. And I'm forgetting something. Hopefully you figured out what I'm forgetting. I'm going to take this number, and actually that's not the right number. So I have 1.7777, a bunch of sevens, and then 8 times 10. And I'm going to use the x to the y. 10 to the negative 12. Actually, I've already done the exponents. I've done the I've done the 10, so I didn't need to worry about that. I just need to take this number and multiply it by 100 to get my okay, clear. Who was it that had the thing where you clear the calculator 5 times? Anyway, 1.778 times 3.2. And I was donating a double donation of platelets, so I actually need to multiply this by 2. That's what I had forgotten. And I get 11.3, we'll call it 11.378. And I'm going to put these in parentheses and multiply by my 2. Come on. And I forgot what I got. 11.3. Whoops. And I multiply that by 10 to the minus 1, and this is hours. And actually, if I multiply by 10 to the minus 1, that's like multiplying by 1 over 10. It's like dividing, so it's actually 1.1378 hours. And that's about how long it took me to donate the platelets. Anyway, if you have questions about scientific notation, please send me an email.